Hello. Today we are going to be talking about angles. So this is just a video to help you guys get some good notes in case you're having trouble with this topic, or maybe you just want a more clear understanding of the geometry behind angles. So we're going to be discussing that today in 7 minutes or less. So an angle, let's look at this real fast, is a figure formed by two rays sharing a common endpoint. And that's kind of a technical way of putting it. So we're going to look at the types of angles as a way to explain that. Ignore my beautiful sunset down there. That's no longer relevant. But so types of angles. There's congruent, right, acute, obtuse, and straight. So a congruent angle is two angles with equal measurement, or should I say are two angles with equal measurement. So let's say I have this angle right here made of two rays, ray number 1 and ray number 2, and they share this common endpoint right here. That's what this definition means. So here's one 90-degree angle, and here's a second 90-degree angle. They would be considered congruent because they have the same measurement. Now, a right angle is a 90-degree angle, and you can see, as indicated by this red arrow, that all right angles are going to be perfectly 90 degrees, just like our two congruent angles up here. An acute angle is an angle between 0 and 90 degrees. So we marked a 90-degree framework right here, you can see in the blue, and then this red arrow, anywhere in the space between these two blue lines would be considered an acute angle. So if we had it at 89 degrees or if we had it at 1 degree, that would be considered an acute angle. So we just have a 45-degree angle to symbolize that. An obtuse angle is an angle between 90 and 180 degrees. So here's our 90-degree outline again. And this arrow right here is past that 90-degree marker. So anything past this marker is going to be considered obtuse. A straight angle is perfectly 180 degrees. Now this may just seem like a line, but it's actually a straight angle. It's considered an angle. So an 180-degree angle is a straight ray like this. Perfect. And y'all can ignore this beautiful sunset that I drew. Now, a vertical angle, we'll talk about the technical definition, is a pair of angles opposite each other formed by two intersecting lines, also known as opposite angles. Now, if you're following along and writing notes, you might want to write that down. So let's say we have this ray here and this ray here, and they are intersecting lines. And they form pairs of opposite angles. So A and C are opposite angles, and B and D are opposites because they're catty-cornered to each other. Now, the concept of vertical angles means that A and C are technically the same measurement, like they're the same degree. So we can prove this by looking at the lines themselves. So we know that a straight angle like this line is 180 degrees, and we'll color it just so we can get a good idea of what we're talking about. So this yellow line, A and B both rest on this yellow line. So A and B must add together to equal 180 degrees because that's what a straight angle is equal to. So likewise, that would mean that A is equal to 180 minus B. That would be how you get this measurement. So then if we're looking at C, and we'll color this one, let's color this one green. We'll keep it blue. Let's say this blue arrow has B and C resting on it, if you can tell. B and C both rest on this. Well, that means that they equal 180 degrees also. So likewise, C is equal to 180 minus B. Well, if you look, 180 minus B, 180 minus B, that means A and C are the same, so A and C are congruent, and so if they're congruent, they're vertical angles, because they're vertical to one another and they have the same measurement. Super nifty. Okay, great. So what we're going to look at now is a very confusing concept called the parallel postulate. So get ready for this definition, it's going to blow your mind. Parallel postulate. if a line segment intersects two straight lines forming two interior angles summing to less than 180 degrees, the two lines, if extended indefinitely, meet on that side. Now that sounds really long and scary, but really what it means is here is our vertical ray right here, and here's two intersecting lines. Now these two intersecting lines, if you can't tell, are parallel to one another. So if they're parallel, that's great, all things are great. That means that all these angles are vertical angles as indicated by the red lines. Everybody's happy. The parallel postulate says, well, if these two angles are no longer vertical, so let's say this one is red and this one is yellow, then at some point, because A and B sum to less than 180 degrees, these two lines are going to intersect if they're extended forever, forever, forever. As you can see, they're almost intersecting right now. So they would be perpendicular to one another. So that's basically what the parallel postulate is saying, that if these two angles sum to less than 180, like they normally would on this blue line right here because it's a straight angle, then the yellow and red arrows are going to intersect. Real fast, we'll give you guys a problem. So you can just pause this and do an angle chase problem, and then we'll see what you come up with. So go ahead and pause now that you know what vertical angles and parallel postulate works. So you just take a pause, try to solve, and then I'll show you the answers. Hopefully you paused and weren't lame. So here are your answers. Hopefully you guys learned something, and thanks so much.